All right, welcome everybody to today's CBCS seminar. Today we have Professor Ross Thompson joining us from Canberra to speak. Ross is the founding director of the Centre for Applied Water Science and the co-director of the Institute for Applied Ecology at the University of Canberra. Ross is a freshwater ecologist with interests in the study of biodiversity and the restoration of landscapes. His fundamental research is in food web ecology, seeking the rules that determine how natural communities assemble and persist, and his applied research addresses the way in which food webs can be influenced by anthropogenic factors, including urbanization, land clearance, pharmaceutical contamination, river flow diversion, restoration, and invasion. Ross leads the basin-wide monitoring program monitoring the effectiveness of environmental flows in the Murray-Darling, and works closely with rural landholders, Indigenous groups, and local communities in his work. So thank you so much for joining us today, Ross. I have also been assured by Martine that he is one of the loveliest people going around and an integral part of the NESP2 bid. So thanks for joining us, Ross.
It's a great pleasure, and thank you for the invitation. And just to let you know, Martine has only said that because I invited Martine to give a seminar. She somehow not only dodged doing that, she got me to give a seminar for you guys. So yes, that's why she's saying I'm lovely, because she's feeling bad. It's great to be here and great to see some familiar names on screen. It's a real pleasure to talk to you guys today. I'm just going to share my screen with you. And all going well.
Yep.
You can see my screen.
You got it.
Okay. So what I want to talk to you today about is probably something a little bit different. I was intending to talk really about the about some of the more sciencey stuff behind this, but when I started to write this talk, I was sort of aware of really the importance of the context of it all. And so today is going to be a bit of a journey through some of the history of how we've got to where we are with adaptive management and freshwater in Australia. I'd like to begin by acknowledging the Indigenous people of the land, express my respect for their elders, past, present, and emerging, and to commit myself to working in partnership to redress past wrongs and to ensure a healthy future. In particular, I acknowledge the Ngunnawal people, the traditional owners of the land on which the University of Canberra is based, and express my respect for their elders past, present and emerging. Yama, and from my mob in New Zealand, tēnā koutou, tēnā koutou, tēnā koutou katoa. So this is a sort of an iconic image in natural resource management in Australia. And this is an image from 2010, and it's a bunch of extremely annoyed people in Griffith burning copies of a draft piece of policy from government. And so what I want to talk to you about today is how did we get to this point and where have we gone from that point? And also a little bit about what comes next. And so today I'm going to begin with actually historical context. And I apologize if that's a little bit long, but I think it's actually really important to understand how quickly, but also some of the baggage that's come with the process of water reform in Australia. I'm going to briefly brush up against climatic context because looking forward, it's obviously a key element of water management. And then I'm going to spend a little bit of time explaining the Murray-Darling Basin Plan as best I can before we talk about some of the science behind water for the environment in the current world and some of the future trajectories and objectives that we have for water management. So to begin with a little bit of history, and if everyone knows this, I apologize, it's Australian Water Management 101, but it's important to remember that there is a key point here, and that's the right to take and use water in Australia is absolutely sitting with the states and territories. It explicitly in the Constitution says that water management is managed by the states and territories. And you can imagine that during Federation, there was very good reasons why people hang on to that. So let's begin with the Constitution, the vibe of the Constitution. That said, states and territories have worked together for a range of outcomes, and there has been a dramatic period of reform driven by a combination of drying climate and increasing demand. And so the drivers climatically and in combination with increased intensification of agriculture have forced the states and territories to work together, and they do so, but it's a process of negotiation and it is very much a process of consensus and compromise. All of what I'm talking about today really happens against this backdrop. So this is the flow in gigalitres per year that comes down the Murray-Darling system. And the Murray River is one of the most variable rivers in the world. So we probably all think of the Amazon River being in channel and then up onto the floodplain. The ratio of high flows to base flow in the Amazon River is about 2 to 1. The Murray is closer to 400 to 1. And so it's an incredibly variable system. And year to year, you can see the variation from the 1917 floods, which are absolutely massive, 28,000 gigalitres of water coming down the river, through to years when the flow is well below 500 gigalitres of water. So a massively variable hydrological backdrop for our story today. And as development happened in the river, there was a series of phases. Initially, the river was managed largely for navigation. So a lot of the habitat was stripped out of the main channel, and that was just simply to allow boats to move up into the interior of Australia. By 1920s, water levels had dropped in the river sufficiently that navigation was becoming less and less feasible, and the severe droughts at the end of World War I and then again at the end of World War II basically meant that navigation along the river was no longer feasible. In order to enable that movement along the river, there was an agreement between the states in 1915 called the River Murray's Agreement, the River Murray Waters Agreement. It took 8 years to negotiate. The Premier of South Australia at the time described it as a useful business bargain to ensure that South Australia could guarantee some water finding its way down the river to South Australia. And this created the River Murray Commission, which ran the river on behalf of all of those states together. And it was, for a long time, really an agency that was mainly to do with development. It was largely about putting in locks and weirs, building dams, developing irrigation systems, and doing that in collaboration between all of the states. Increasingly, though, as we moved into the 50s and 60s, environmental problems began to be a really big part of what we were seeing in the Murray. And so groundwater salinity became a big issue, and from the 60s, there was significant capital expenditure in intercepting salty groundwater before it entered the river, and those interception schemes go on to this day. And then really from the late 70s, increasing concern over the environment. So the River Murray Commission went through this transformation from what was really a development organisation to much more a science and research focused organisation. That was sort of established in the fact of the agreement in 1982 when the River Murray Waters Agreement was renewed. And that finally sort of talked about the sharing of water management, not only for purposes of development, but also to ensure sustainable use. And again, all of this against a backdrop of extremely variable hydrology. So if you haven't seen these figures before, these are little maps of Australia which show the rainfall deficits across Australia, the rainfall anomalies across Australia. And you can see, immense amount of variability and some really substantive drought events. So the Federation drought, which really strongly affected the East Coast, World War I drought, World War II drought, which is arguably one big drought that began in 1940 and worked its way through 1947, the 1960s drought, and then through the 70s and 80s. Quite patchy in terms of what parts of Australia they affected, but nonetheless, really profound examples of where we have very, very dry periods in Australia's history. And in the 1980s and 1990s, following on from the River Murray Waters Agreement, there was really increasing evidence that the basin was becoming environmentally degraded. 1991 and 1992, there was what was the largest blue-green algal bloom ever observed in the world along the Darling River. It very much hit the news locally and internationally, and it was seen as a sign of degradation in that system. And so there became a discussion around how some of the ongoing issues with water allocations might be addressed. The water allocations in the 1980s were basically linked to land rights. You bought a farm and there was a set of water take rules associated with your farm, and some of those were pretty old. Some of them were you can pull the board out of this irrigation race and take water between 2 p.m. in the afternoon and 6 p.m. in the evening, 3 days a week. And it was literally the farmer goes down, kicks a board out that takes water out of the river. A bunch of them were to do with the diameter of a pipe and how much it could pump from the river. So these are quite old-fashioned and very varied. And there was a huge amount of water allocations that had been provided with land rights, but had never actually been used. And a colleague and friend, now sadly no longer with us, Peter Cullen, was very vocal at the time that there was an emerging crisis around the Murray-Darling Basin because of this combination of environmental degradation and water allocation, which actually hadn't been used to its full extent. There was a wet period really in the late 80s and 90s, and Peter was passionate about the fact that that was our opportunity, while it was reasonably wet across the basin, to push for water reform. And Peter was aware, as many other people were becoming aware, that this is the picture of water allocation in Australia. So there's the average natural flow to sea, and this is the picture of what water is allocated to be taken from the river in any given year. And you can see that the water allocations, if they were all utilised by 2020, we're going to be close to taking the entire flow of the river. And so this is recognised as being utterly non-sustainable. So the Murray-Darling Basin Agreement in the 1990s, the largest catchment management program in the world, covering the full basin, 1 million square kilometres, was an agreement between all parties to cap water takes from the Murray. And if they'd been lucky, it would have been seen as one of the most successful natural resource management agreements in the world. They weren't lucky. So, the Murray-Darling Basin Agreement. So what the Murray-Darling Basin Agreement did was say, well, let's take the water allocations that are already been given in 1988, let's take what's planned to be by 1994, halve the difference, and we'll cap water allocations at this level. So, into the early 1990s now. The onset of the Millennium Drought, inflows are less than half of the long-term average, and across the basin we're seeing really, really major signs of ecological collapse. Fish kills, major algal blooms. The lower lakes are becoming very salty, so historically a freshwater system. And there's increasing evidence in ecological research that starts to explore these questions. But the system continues to dry down, and in 2000, for the first time since settlement, the Murray River ceased to have sufficient water to reach the sea. So it essentially dried into a set of whirlpools. And I mentioned that the cap could have been seen as an incredible piece of natural resource management if it had been lucky. Well, the cap was obviously set at around 10,500 gigalitres per year of diversion. By 2004, the whole flows of the river were close to 4,000 gigalitres. So yes, there was a cap, but there was also no ability to take any of that water out of the system. And so the system had begun to dry down really since the 1970s, and you can see this big step change that occurred in the mid-70s around the average inflows to the river. And then that continued again into the early part of the 2000s, and there was increasing concern that actually there was another big step. And so the National Water Initiative arose out of this. National Water Initiative really heavily pushed by Peter Cullen in association with a bunch of political colleagues. And it created this idea of environmental water, that we needed to reclaim water from irrigation and to use for the environment. We needed to deal with the fact that we'd allocated water in the river that possibly didn't exist and would never exist again. We needed to be more efficient with urban water. And almost because of the era in which it was formulated, the solution to this problem was considered to be a market mechanism. How can we expand the trade in water? How can we have pricing for water storage and delivery that truly reflects the costs of those practices? And the idea was a perfectly simple one. It was that water would move from the least efficient producers by use of water through to the most efficient. And the scenario was said, and I don't think anyone realised the social implications of it. Well, a wheat grower can choose not to plant wheat this year and trade the water allocation downstream because a horticulturalist has to keep their trees alive regardless. And so when we think now about the way the water market works, and people are saying it's an outrage, we've got rid of wheat growing throughout the basin, but we've supported a whole lot of almond trees in South Australia, that's exactly what it was supposed to do. It's just now we're seeing the social costs of that. So 2004, the National Water Initiative, still a really visionary document, really, in terms of what it said about the next 20 years, really, of water management in Australia. The National Water Initiative kicked off a process of progressive decoupling land and water rights, such that water could be traded away from a farm or a valley. Initially limited water trading, that was increased in scale through time. It was recognised that they needed much better water metering and robust data as the basis for the policy. And the National Water Initiative is important in that it talks about the role of science as a driver of policy. And much of what has come since has reflected the fact that all of this initiative and era of reform was done within an adaptive management framework where they said, we don't know everything, we need to make a set of decisions. Science will change, and we want to have the policy as being able to respond to the changing scientific base. In terms of describing the ecological state of the basin, the Sustainable Rivers Audit was a process which began and has been several iterations of it since between 2004 and 2008. And this was a unified program jointly funded by the states and the Commonwealth, drawing really heavily on foundational work that had come out of 2 generations of CRCs and seeking to generate a report card for how the basin looks. Sustainable Rivers Audit looked something like this. And this map should come with a public health warning. And the public health warning should say the colours on this map have been affected by political influence. The first iteration of this map had green for healthy, orange for not so healthy, and red for not healthy at all. But unfortunately, the minister at the time was very uncomfortable with those colours. So completely counterintuitively, on this map, green means poor or very poor. Bluish colour means okay. Purple means good. And pale yellow means extremely poor. So though it may not strike you as when you look first at this map, actually what you see here is a system that's in really poor ecological condition. So the subcatchments that are shown there are all pretty sick. The Paroo is not. The Paroo is also extremely dry, has almost no agricultural development, very few takes of water. So it's the healthiest system, but it's also essentially an intermittent system. So we knew the system was in poor condition, and then flows continued to decline. And so moving through now into the mid parts of the first decade of the 21st century, and we are seeing really, really low inflows, unprecedentedly low inflows. And in 2006, we had the lowest inflows on record. This provoked the Commonwealth to intervene and say, we need to ensure that there's water security. And so they proposed the National Plan for Water Security. It was a political bun fight. For those interested in political science, it's like sort of a case study, but nonetheless, I'm going to talk very, very briefly about it. Essentially, the Plan for Water Security proposed establishing a MurrayDarling Basin Authority to create a basin-wide plan for water management that would have a new sustainable cap that would manage water quality and salinity. It would recover water for the environment and apply it, and it would manage and will create and then manage the water market. So that was the intention of the National Plan for Water Security. Now, remembering that back to Australian Water Management 101, the Commonwealth has absolutely no rights to manage water. And so a very, very odd player becomes the basis for the Commonwealth for intervening in water management. This dude and his mates. This is an Australian basin. I think the Australian basin is looking as surprised at being involved in water management as you are, probably. And essentially what the Commonwealth claimed was a right to intervene in management of water on the basis of their obligations under the Ramsar Convention on Wetlands, which is reasonably obscure, you might say. But essentially they argued that we can't meet our Ramsar obligations, so therefore we have to intervene and manage water. That continues to be the legal basis for all of the water reform journey that's happened in Australia over the last 20 odd years. This was then written into legislation via the Water Act in 2007, and that created the legislative basis for the government, the Commonwealth, to be involved in water management. Now, meanwhile, it got really dry. And so the states were bickering about whether to sign off on the National Plan for Water Security, but finally they were pushed to do so after a series of compromises were offered by the Commonwealth. Particularly from South Australia, the ability to store water in upstream dams that were in New South Wales and Victoria in order to ensure they could meet critical human needs for Adelaide in particular. A continuation of the state's role in setting water allocations, and essentially $1 billion sweetener. Victoria were the holdout state, they didn't want to sign this agreement. $1 billion investment in the Food Bowl project in Victoria, which was largely about piping open irrigation channels and ensuring that their evaporative losses were reduced. So a big deal, lots of money. So finally we had the Murray-Darling Basin settlement. Meanwhile, it got drier still. And so 2011, 2012, 5 gigalitres of water came down the Murray. This is 1.5% of the long-term average flows in this system. So it's incredibly dry, incredibly dry. And at the time when we were involved with some of the water management questions, the questions were, where can we take truckloads of water to put it into pools within the channel in order to save particular fish species? There was one quite high profile event where this Victoria pumped water into a water hole and prevented the Murray hardyhead from going extinct. So this was really intervention on the sort of firefighting level. And then it rained. And when you talk about water management and in fact natural resource management in general, crises are really, really important because they drive change. But then what you almost need is a bit of time away from crises in order to implement some of that change. And we were fortunate in the Murray-Darling Basin, that's exactly what happened. It rained really heavily in 2012 and ended what is estimated to have been the driest decade of the basin in 3,500 years. So it was a substantive drought event, and then it was ended by a rainfall event. So you can see what we call the Millennium Drought here. It can be argued when it starts. The most sort of up-to-date description of it suggests that it sort of began in 1997, lasted all the way through to 2011, 12 essentially, and then it rained really heavily. Now in some catchment, that year 2012 was actually the wettest year on record, so it really was a dramatic breaking of the drought. So that's the sort of history of what got us to the Murray-Darling Basin Plan in the late 1990s, early 2000s. The climatic context, of course, is also worth considering. Throughout the basin and throughout Australia, obviously, we have seen progressive climate change. And so this is, I think, a really interesting graph which looks at density, annual mean anticyclone density across the Australian region. And you can see just an increase in anticyclone events causing dry conditions. When we look at trends in mean temperature, all of you, I'm sure, have seen these figures before. These are the trends in mean temperature across 1970 to 2019. Trend in maximum up on the top right there, trends in minimum down on the bottom left. So it's getting hotter. And in fact, the mean temperature anomaly illustrates that really well. So we are not having cool years anymore, we're having lots of hot years. If you add to that rainfall, the trends in rainfall have much larger variation around them, but nonetheless, there is this trend where the north and west of Australia has become much wetter, but the south and east has become much drier. And in particular, that's associated with a failure of both spring and autumn rainfall events. So in fact, summer rainfall has increased slightly across much of this region, but spring and autumn, traditionally the high rainfall events, times of year, the rainfall has almost gone from those periods, apart from this year when it's back. And so if we look at rainfall anomalies, a lot more variation, but you can see more red than blue on that, that there's large rainfall anomalies, negative rainfall anomalies. And certainly from the wet events that ended the Millennium Drought, there's been a series of relatively neutral drought events leading up to the two most recent years. So the 18-19, which are some of the most intense drought years in the southeast on record. That drought hasn't been given a name yet, but I think it's going to be, because the reality is straight before the most recent rainfall events, it was the most intense drought recorded in the southeast of Australia. And of course, looking forward makes you want to turn to drink, frankly. The climate projections for the Murray-Darling Basin, which are shown here, ranged from a median projection which suggests about a 10% reduction in inflows to the river in the northern basin, 11 in the south. There are some projections that suggest the north might get slightly wetter, but the dry end projections are 20 to 30% reduction in annual runoff, and that's at a 1 degree global warming scenario. So this is a catchment which is very dry, it's dried through time, and the projection says it will continue to do so. So how does the plan as it currently sits sit within that context? Now, the Murray-Darling Basin Plan, which was finally passed in 2012, its primary goal was to determine how much water could be taken from the river. And this is what's referred to as the Sustainable Diversion Limit, and I'll use the phrase SDL from hereafter. And that's the amount of water that can be taken for all consumptive uses that won't have a negative effect on natural environment, essentially. And so the Murray-Darling Basin Plan process was to describe all the values and assets across the basin, work out how much water was actually available in the basin, work out how much water the environment needed, and then extract a plan which said how much water is then left over to be used for agriculture. And of course, the question that we asked at the time, and actually this was asked by a minister who appeared at a working group, how much water does the river need, really? And of course, as an ecologist, the answer is, well, all of it, obviously. The real question that we were asking was, how much water does a river need to support the critical assets we've defined? This is absolutely a management question. It's not about restoration. You're not restoring the system. If you're restoring the system, you would need to restore all of the flow to it. But the reality is, how much water do we need to leave in the river in order to support critical assets? And we already knew quite a lot about the ecology of this system. And so we knew that it was really important to get water up onto the floodplain sometime, to support exchange of materials and to support the life cycles of iconic things like river red gum. We knew that frequency of and timing of flood events up onto the floodplain were really critical as cues for fish breeding. In this case, a yellow belly, golden perch, big-bodied fish that basically only breed if you get little floods. And we knew that water in wetlands was really important, and how long the water stays in wetlands was really important for supporting water bird populations. And again, that's critical because going back to what the basis for this reform was, it was around the Ramsar Convention, and the Ramsar Convention is very, very strongly slanted towards protecting water bird habitat. So how much water does a river need, really? The data we had was both spatially and temporally patchy, and that's probably not unexpected. The hydrologic data was pretty good, and there'd been a generation of work, really, that was world-leading in terms of describing where the water was in the basin. And so what we did was put those two things together and saying, where is there sites across the basin where we have good hydrologic data, we have reasonable ecological data, and which we think will be representative of the ecosystems across the Murray-Darling Basin. And the argument was, if we can work out how much water those sites need, then we can scale up and work out how much water the whole basin needs. So 24 sites were identified. They're originally called hydrological indicator sites. Just some names of sites you may be familiar with up towards your end of the world: the Guida wetlands, way up north on Kimilora country, the Macquarie marshes, Barma Milawa, some of the iconic river red gum forests of the main Murray, all the way down to the Coorong and the lower lakes, down where the river enters the sea. For those sites, for a suite of ecological assets that we decided were important, we worked out how much water they needed and when. And it was all about taking the existing hydrograph, which is shown as the green line there, so the amount of water that's coming down the river at various times of the year, and trying to get that hydrograph to more closely resemble the orange line, which is what the river would have flowed like without development. So there's a lot of modelling that goes on behind the scenes here around modelling what actually the river flows would have looked like in the absence of the dams and the water abstractions and the floodplain harvesting that goes on now. So the sort of thing you might imagine doing would be to increase the amount of water so that you can inundate some river red gums, maybe extending the time that the river's sitting at a higher level so that you can support a bird breeding event. So it's really about augmenting the flows we have using environmental water. This is all described in something called the ecological elements method. I think it's really, really neat still as a piece of modelling that says how can we pull everything together in the absence of perfect knowledge and make some management decisions. The ecological elements method identified around 3,600 gigalitres of water needed to be recovered for the environment. And so that was an interesting process done very quickly. If you want to read a description of this, there's a fantastic and fascinating paper that I just happen to be an author on, which brought together the Murray-Darling Basin Authority staff together with some researchers from our research group here at UC to reflect on that period of time and to try and extract the narrative of how that discussion went between science and policy. So, environmental water requirements were established. We needed to recover 2,650 gigalitres of, 3,650 gigalitres of water from the river, from irrigated agriculture in order to support the environment. And that was what caused the fire. The guide to the basin plan, which was released to socialise the idea of the amount of water that was going to need to be recovered, was poorly socialised. The consultation was inadequate. It was put out into the basin and it became a disaster. Farming communities very, very quickly mobilised against the plan. There were some very high profile protests, and most of the arguments were on the grounds that if you take that much water from irrigated agriculture, it will be a social and economic disaster. And the social and economic work that had been done as a part of the development of the guide were really, really poor. In fact, completely inadequate, I would argue. And so there was no counterpoint. You couldn't come back and say, no, actually the social and economic costs aren't going to be that high. And as it turns out, they really aren't. But we didn't have the research to actually make that case. So essentially we went back to rethinking the environmental water requirements, and this was an utterly political process. So there were things like the minister coming into the room and saying, I don't know how much water this river needs, but I know it starts with a 2. Comments like that. And ultimately, that number did start with a 2. 2,750 gigalitres of water were agreed upon to be recovered for the environment, and that was what allowed the basin plan to come into effect. How is this all supposed to work? Well, the basin plan essentially says we need 2,750 gigalitres of water, and originally all of the water in the river would have been available for abstraction, and in fact some water that wasn't even in the river was available for abstraction. But the way in which that was to be reformed was that there would be a bunch of water set aside for system flows. And that's because the Murray itself had ceased to flow in 2000. And that had had all sorts of implications in terms of water takes for town water supplies, for maintaining the gates on some of the dams, and indeed for keeping the Murray mouth open. So system flows were carved off as a separate partition of water. A fraction of water, 2,750 gigalitres, was to be recovered for the environment and is referred to as the environmental allocation. And then the remainder of the water is the sustainable diversion limit, the water which is available to be used for other things. So that was the process that we were going through. The initial process was of water recovery. How do we get the water back that's already been allocated? And there's all sorts of bizarre things that come out of this time, including the fact that the first iteration of water buybacks brought back water that actually wasn't available, hadn't been in the channel for about a decade, and it was what was referred to as the purchase of dry water, the purchase of allocations of water that actually couldn't ever be taken. So there's there was a process there of water buybacks, and of course you'll be aware that that became extremely controversial. About 1,200 gigalitres of water were purchased back, which was a major movement of capital from the Commonwealth to the private sector. Considerable investments were made in infrastructure projects, many of them on private land. particularly metering, but also creation of new irrigation infrastructure. Then there was big state projects, and then a bunch of other investment. This is a little bit of a dated figure. This is back when only 1,900 gigalitres had been recovered. But you can see the majority of the water was recovered through that initial buyback. And for those of you who keep up with the media, you might have seen the ABC Four Corners episode called Cash Splash, which talks about whether that purchase of water was done in a transparent, legal and ethical way. And I'm not going to comment on that because many of those matters are still before the courts. Having achieved some of that water back, we've now moved into a phase where we're now in the water planning phase. And the water planning works essentially like this. The Murray-Darling Basin Authority creates a water plan for the whole basin and shares it with the states. The states then, for each of the catchments within their area, develops a water plan, and that water plan goes back to the Murray-Darling Basin Authority and says, here's how much water we need in this river, here's how we're going to recover water back from irrigation, here's our plans for using environmental water over the next year. Once that plan is agreed upon, the environmental water allocation then moves to the Environmental Water Office, the Commonwealth Environmental Water Office. Because it controls a massive public asset in environmental water, which has a monetary value, the Environmental Water Office has a whole set of arrangements around probity that are really, really important. Water which is allocated for consumptive use can be traded, and all of that goes on in the background. In terms of actually how much water is taken, and in terms of actually how much water is recovered, the compliance for that all sits at a state level. And it's this compliance which has caused, again, most recently, some controversy. So you may have seen the Four Corners episode called Pumped, suggesting that people had been pumping more water than they were allowed, the single largest financial theft in Australia's history in one case, and about 3/4 of the gauges that are supposed to monitor pumping being disabled in some way. So the Murray-Darling Basin Plan is now in place. And so we're managing in a world where we have environmental water. And I want to spend the next little chunk of time talking about how we manage that asset. I, as was mentioned in the introduction, am co-lead of something called the FLOMER, Flow Monitoring, Evaluation and Research Program. This is about a $15 million program that relies on work from teams based in 7 selected areas across the basin, and those selected areas are shown in the grey box there, and then a research team that sits at the basin scale, which brings all that data together. So I want to quickly talk about the way that this program works, because it's part of the sort of ongoing attempts to ensure that we are efficient and transparent about our value we get from environmental water. Basically, this entire research program is based around 6 research themes and then a set of cross-cutting activities which are supposed to link across the themes. I'm not going to go into great detail about any of them, but I will at the end provide you with a link if you want to go and look into the project in some more detail. The project is then divided into 2 major components, a research component and an evaluation component. The evaluation component essentially takes research outcomes and feeds them directly through to water managers. So there's day-to-day, certainly week-to-week, conversations between scientists and water managers on the ground who are making decisions about when or when not to run water down the river. And probably the most profound benefit that's come out of this entire process has been the willingness of water managers now to pick up a phone, talk to a scientist and say, we've got an opportunity to put some water into this wetland because there's been a natural rainfall event. Do you think we should or not? And so it's adaptive management, I think, as probably realistically can be. Within the research component, and this is the particular part of FLOMER that I look after, there is a set of research activities. And really, I'm just going to talk about one of those today, which is the bioenergetics work that we do. The bioenergetics work benefits from being able to measure some fundamental processes. So obviously, in a stream channel, we have both photosynthesis going on. We also have respiration going on. And we can measure the oxygen profile in a part of a stream and work out how much cross primary production and net ecosystem respiration is going on. We do that by measuring oxygen profiles across a day-night cycle. So there you can see a day-night cycle, the sort of purpley color indicating the photosynthetic active radiation, the blue line indicating the oxygen concentration in the water. So you can see that during the day, photosynthesis is pumping oxygen into the water. Some of that's being used for respiration, but we get a net increase in oxygen. And then during the night, we get a reduction in oxygen because photosynthesis is no longer happening. And that allows us to estimate respiration rates. So by fitting models to these curves, we can estimate how much productivity is happening in these channels. And we can then relate that back to flow. The system I'm going to talk about today is the Lachlan River system, which is inland New South Wales. It's an interesting system. It's distributary. It very rarely actually connects to the Murray, except in very, very wet years. Fiona Dyer, who's shown there, leads the research team that works in this area. And we were talking about the area up around Condobolin, Forbes, Hillston, that sort of area. And this is now an area where we've been managing environmental water for 5 years. And gets both dry and very wet backgrounds. And you can see the red circles there indicating when we've used environmental flow for various purposes. I'm going to concentrate on the most recent set of data that we have, which is against quite a dry backdrop. It's now become quite wet. There's been a lot of rain up there in the last month or so. And you can see what environmental flow does if you just look on the ground. So this is the Great Cumbung Swamp, which is the terminal system for this river. That's pre-environmental flows. And so you can see there's a bit of water in the main channel. But then when you add environmental water, as we have in the second picture there on your right, then you can see that we've succeeded in watering in a whole lot of wetlands and billabongs and little lake systems. And what we can do is look at when we've provided those environmental flows, shown here by these grey bars, and we can look at the primary production response. So what you're seeing on this graph is the temperature along the top there. So you can see it's ranging around 10 degrees. You can see the dark blue line, which is indicating the discharge, how much water is coming down the river. And then the black triangles there indicating our estimates of primary production. So how much carbon is being fixed and fed into the food web. And you can see some relationships there, but it actually takes a really proper look at an individual flow event to try and understand whether or not we are generating a productive response using environmental flows. So the question we really want to ask is, if we do generate productivity, does it then get passed up food chains to result in positive outcomes for the things people really care about, like native fish? Here's an example of our most recent work, and this is unpublished, and so it's please treat it as such. What you're seeing here is an orange trace line which shows water temperature. So you can see that as we're moving into summer, water's becoming much warmer. You can see a green line, which is the contribution of Commonwealth environmental water. So that's a peak of water that's been released from the dam at Wyangala down through the river for environmental outcomes. And then the blue dots are indicating gross primary production. So the amount of carbon response we're seeing. And I can see, and I hope you can too, a really clear peak associated with environmental water. So when we provide environmental water, we are putting more carbon into the food web. And when we start relating this then, and this is the same flow event, but this time those grey bars have been superimposed, we can actually see a spawning response. So we're taking fish larvae here, we're working out when they were born, and we can show that our little productivity pulse and flow pulse generated a fish breeding event and allowed those fish to hatch and move into the population. What we're moving on to at the moment is a much more complex story, which is looking at waterbird responses. There's these huge iconic waterbird aggregations that happen within the basin. And those are really iconic events, and they're things that we want to try and understand. How much energy do we need to put into a system and for how long before we can produce these remarkably ugly little beasts? So, water for the environments. That's the way we're doing things now. I want to think about where we're going next, and I'll be very brief here. We've come from a history where a crisis, some of the lowest flows on record, generated policy reform. We had a good understanding of the underlying ecology, and that allowed us to quite quickly move to an adaptive management phase where we're managing for particular environmental assets. But going forward, we're challenged by a drying climate. We're challenged by a political environment which is increasingly partisan. And for those who haven't seen this paper in PLOS, it shows the networks of interactions between the left and right of politics in the US through time. So it shows that increasing partisanship that's occurring in politics around the world. And we continue to have challenges around groups that we have not effectively engaged with in water management, and in particular, our Indigenous colleagues and Indigenous Australians. This is an area I've been working actively in with my colleague, Brad Mogridge, looking at how we can bring Indigenous cultural values into water planning and trying to provide a way forward to achieve that. And of course, across all of that is the fact that we have been managing water as though it isn't connected to land, when of course it is. And the point we're getting to now is where land management and water management are separate and are actually constraining our ability to see environmental flow responses. And so, for instance, in the Lachlan River, we ran an environmental flow down during the drought and generated a flush of response from wetland plants. There was then an outbreak of pigs who ate it all. So there's a response to environmental flows we couldn't see because essentially there was a terrestrial pest problem. And at the moment, there's no effective way of combining management across land and water to achieve the best outcomes. So as we move forward to the next generation of water reform, which is almost upon us, the Murray-Darling Basin Plan will be reviewed in 2023 and then again in 2026 for its final review. We need to ensure all parties are present at the table across land and water, Indigenous and non-Indigenous. We need to regenerate trust and transparency in local enforcement of water management. We need to ensure that we maintain this really science-focused management approaches, where we clearly communicate outcomes to environmental water and make sure that we can justify the use of that environmental water, given that providing it does have social and economic costs. And finally, and one of the reasons I'm really pleased to be talking to this group today, is the need to really weave together land and water management to achieve the best biodiversity outcomes. Silos generated by administrative structures and by legislation are not helping us. And what we need to do is be much more effective at working across the land-water interface to generate management outcomes. I'd like to acknowledge, before I finish, the many people who contribute to this project. The FLOMER project is a very large consortium that builds on an abundance of previous work. If you are interested in the program, go to our website. There are also regular webinars if you want to learn more about the research. I want to particularly acknowledge Fiona Dyer, who leads the Lachlan team, but also other colleagues across a whole variety of agencies. And I'm happy to invite your questions. Oh, and here's a picture of a wetland, because it makes everyone happier to look at a wetland.